Which came first, the chicken or the egg? Did the universe have a beginning, and if so, what happened before then? Where did the universe come from, and where is it going?
Luck, well, we have been very lucky. I mean, my family and Stephen and everybody, you have your disasters, but the point is that we have survived. Everybody has disasters, and yet some people disappear and are never seen again. Flying bombs were very alarming, because they came buzzing over, and then they would cut out. And when you heard the bang, you knew it wasn't you, so you went back to your meal or whatever. But one did fall, quite close to our house, and it blew the back windows out, so that the glass was sticking dagger points all out of the opposite wall. When Stephen was born, we decided he'd better be born in Oxford. So while I was staying in the hospital, I went to Blackwell's in Oxford and I bought an astronomical atlas. One of my sisters-in-law said, "This is a very prophetic thing for you to have done."
How real is time? Will it ever come to an end? Where does the difference between the past and the future come from? Why do we remember the past, but not the future?
I can remember the day when we travelled through London and the blackout was over. And the trains, instead of being shut in by blinds, so you just travelled in a train, we were coming over one of the bridges. And all the lights, well, such lights as were left, were on in London. But it was also a completely starry night, and you could see them right all. It was beautiful. I remember we all used to lie on the grass, looking straight up through the telescope and seeing the wonders of the stars. And Stephen always had a strong sense of wonder, and I could see that the stars would draw him, and further than the stars.
I was born exactly 300 years after the death of Galileo. I estimate that about 200,000 other babies were also born that day. I don't know whether any of them was later interested in astronomy.
My first memory is of Isabel pushing a rather antiquated carriage-built pram along North Road with Stephen and Mary in it, sort of looking very large, because they had large heads and pink cheeks, and they were very noticeable. They all looked different from ordinary people.
I can remember visiting the Hawking home, several times. It was the sort of place where, if you were invited to stay to supper, you might be allowed to have your conversation with Stephen, but the rest of the family would be sitting at the table reading a book. A behaviour which was not really approved of in my circle, but which was tolerated from the Hawkings because they were recognised to be very eccentric, highly intelligent, very clever people, but still a bit odd. My impression of the Hawking family was that they were all like that, except for Stephen, who seemed to be the only normal member of the family.
Stephen used to reckon he knew, I think it was 11 ways of getting into the house. And I could only find 10 of them. I'm not sure where the other way was. On the north side of the house, there was a bicycle shed. Had a door at the front and a door at the back. Above that, there was the window into the L-shaped room. And at the front, you could get sort of round the corner onto the roof. And from that level, you could get onto the main roof. I think one of the ways Stephen could get in was on the main roof. As I say, he was a much better climber than I was. I still didn't know what the 11th one was.
Before the 20th century, it was thought that the universe had existed forever, or had been created at some time in the past, more or less as we observe it today. People found comfort in the thought that even though they may grow old and die, the universe was eternal and unchanging.
I gave up playing games with Stephen, when he was ill that time, when he was about 12. Because he started taking games terribly seriously. We had Monopoly. And first of all, the Monopoly board sprang railways going across it to add to the complications. And then Monopoly just wasn't adaptable enough. It ended up with a fearful game called Dynasty, which, as far as I can make out, because I say I never played it, went on forever because there's no way of ending it. It was almost a substitute for living, as far as I could make out. It took hours and hours and hours. I thought it was a perfectly terrible game. I couldn't imagine anyone getting taken up with that. But Stephen always had a very complicated mind, and I felt as much as anything it was the complication of it that appealed to him.
When I was in high school, I learned that light from distant galaxies was shifted to the red. This meant that they were moving away from us, and that the universe was expanding. But I didn't believe it. A static universe seemed much more natural. It could have existed, and could continue to exist, forever.
We were discussing the possibility of the spontaneous generation of life. And I think that Stephen made a remark which indicated not only that he'd thought of this, but he'd even also come across some calculations as to how long it might take. At that time, I think I made a comment to one of my friends, John McLenaghan. I think that Stephen will turn out to be unusually capable. I don't think I put it in quite those words, but I made some such remark to him, and he disagreed. And so we made a bet on the subject. In our childish way, we bet a bag of sweets on the issue. And incidentally, I reckon that my bet has come correct, and I think I'm entitled to payment which has not yet been made.
The expansion of the universe suggested the possibility that the universe had a beginning at some time in the past. The point at which the universe may have started out became known as the Big Bang.
The first year he was at St. Albans School, he came, I think, third from the bottom. So I said, well, Stephen, do you really have to be as far down as that? And he said, well, a lot of other people didn't do much better. He was quite unconcerned. somehow he was always recognized as being very bright. And in fact, they gave him the Divinity Prize one year. That was not surprising, because his father used to read him Bible stories from a very early age, and he knew them all very well. And he was quite well versed in religious things, although I don't think he makes a very great deal of practice of it now.
Everybody used to give theology. That's a good, safe subject. You don't need any facts or distracting things like that. If you go in for arguing, debating, you can quite happily debate about anything, including theology and the existence or otherwise of God. And then someone gets bored, or Journey into Space comes on, or something like that, and the argument breaks up.
In an unchanging universe, one can imagine that God created the universe at literally any time in the past. On the other hand, if the universe is expanding, there may be physical reasons why there had to be a beginning. An expanding universe does not preclude a creator, but it does place limits on when he might have carried out his job.
When the family went to India, it was arranged that Stephen should come and live with us for a year. He decided it would be nice that we should have Scottish dancing in the evening. Now, mind you, this was quite an ordinary house, but we had rather a lot of room and a large hall. And so we bought some records and a book about what to do. And Stephen took charge. And he insisted that you put on a jacket and a tie. And then he was the master of the proceedings. And Stephen took it very seriously. But then he liked dancing, you see.
There were 4 physicists in my year. Gordon Berry, Richard Bryan, Stephen, myself. I first remember Stephen on an occasion when Gordon and I went up after dinner to his room to try to find him. And Stephen was up there with a crate of beer, slowly drinking his way through it. He was only 17. He couldn't legally go into a pub. He'd gone up to Oxford ridiculously early.
We used to have what we call a gathering net. We used to organise a beer party and various things like that to gather all these colours, many freshmen as we could get, you see, to get them to join the boat club. And that's how we collected him, you see. But the question always to Stephen was, should we make him a cox at the first date or the second date, you see? Well, coxes can be adventurous, and some coxes can be very steady people, you see. He was rather an adventurous type. Never knew quite what he was going to do when he went out with the crew. I think he used to bring his work down with him into the boat sometimes, you know. The sort of thinking gear was going on different levels.
We were asked to read a chapter 10, in a book called Electricity and Magnetism by Bleeny and Bleeny, an unlikely combination, a husband and wife team. And at the end of that chapter, there are 13 questions, all of them final honours questions. I discovered very rapidly that I couldn't do any of them. Richard and I worked together for the week, and we managed to do 1.5 questions, which we felt very proud of. Gordon refused all assistance and managed to do one all by himself. Stephen, as always, hadn't even started. But the next morning, he went up to his rooms at 9 o'clock. And we came back about 12, maybe 12:05. And down came Stephen, and we were in the college gateway in the lodge. "Ah, Hawking," I said, "how many have you managed to do then?" "Well," he said, "I've only had time to do the first 10. And I think at that point we realised that it's not just that we weren't in the same street, we weren't on the same planet.
I once calculated that I did about 1,000 hours work in the 3 years I was at Oxford, an average of an hour a day. I am not proud of this lack of work. I am just describing my attitude at the time. An attitude that nothing was worth making an effort for.
He used to produce his work every week for tutorial, and as he never kept any notes or papers or that sort of thing, on leaving my room he would normally throw it in my wastepaper basket. And when he was with other undergraduates at a tutorial and they saw this happen, they were absolutely horrified because they thought he did this work in probably half an hour. And if they could have done it in a year, they wouldn't have thrown it in the wastepaper basket, they would have put it in a frame up on their walls.
Because of my lack of work, I had planned to get through the final exam by doing problems in theoretical physics and avoiding any questions that required factual knowledge. I didn't do very well. I was on the borderline between a first and second class degree, and I had to be interviewed to determine which I should get. They asked me about my future plans. I replied, if they gave me a first, I would go to Cambridge. If I only got a second, I would stay in Oxford. They gave me a first.
I drove Stephen and his young brother out to Woburn Park, and he climbed a tree. He was testing himself out, I think. I didn't realize. And he did manage to climb a tree and to go along a branch of it and to get himself down. I think he began to notice that his hands were less useful than they had been, but he didn't tell us.
UNIV has these square staircases, which are round but they're square. It was just coming down from one of the rooms. Steve actually fell on the stairs, coming down stairs, and kind of bounced all the way down to the bottom. I don't know if he lost consciousness, but he lost his memory. We took him to either my room or someone's room. The first question, of course, was, who am I? And we told him, you're Steve Hawking. And a minute later, or right away, he would ask again, who am I? Steve Hawking. And then after a couple of minutes, he remembered that he was Steve Hawking. Then we'd say, well, do you remember going down to the bar and having a drink on Sunday night? Or do you remember coxing on the river on Monday? And his memory came back gradually until he could remember the previous day's events and then the previous hour. And then by the end of the 2 hours, he could remember everything. The question was, well, maybe, you've lost some of your mind because of this. And so Steve decided, well, I'll take the Mensa test. We said, of course you'll get into Mensa. But he came back delighted that he was able to get into Mensa. Absolutely delighted.
I felt that there were two areas of theoretical physics I might study at Cambridge. One was cosmology, the study of the very large. The other was elementary particles, the study of the very small. However, I thought that elementary particles were less attractive because there was no proper theory. All they could do was arrange the particles in families, like in botany. In cosmology, on the other hand, there was a well-defined theory, Einstein's general theory of relativity.
It was a very cold year, and the ice on Verulamium Pond was frozen there, and we all went skating. And Stephen managed to skate fairly well, but then he and I were close together. He wasn't skating in a very advanced way, but nor was I, as it comes to that. He fell, and he couldn't get up. So I took him to a cafe to warm up, and he told me then all about it. And it was diagnosed. I insisted on going to see his doctor, because it seemed to me, however long you're going to live, there's probably something someone can do about it, at least anyhow, to make things easier for people. And I won't mention the doctor's name, but I got to see him at the London clinic. And he was rather surprised that I should bother to come round to see him. I mean, after all, I was only Stephen's mother. So he said he was quite nice. I mean, he agreed to see me in a rather grand way. And he said, yes, it's all very sad. I mean, brilliant young man, cut off in the prime of his youth, as it were. But of course, I said, well, what can we do? You see, well, what can we do to sort of, can we get physiotherapy? Can we get anything like that will help in any way? I said, well, actually, no. There's nothing I can do with it, more or less. That's it.
Shortly after my 21st birthday, I went into hospital for tests. They took a muscle sample from my arm, stuck electrodes into me, and injected some radio-opaque fluid into my spine, and watched it going up and down with X-rays as they tilted the bed. I was diagnosed as having ALS, amyotrophic lateral sclerosis, or motor neuron disease, as it is also known. The doctors could offer no cure, and gave me 2.5 years to live.
I went into the graduates' common room and looking really for someone to have lunch with. And there was nobody around that I particularly wished to have lunch with. And then, lo and behold, Stephen walked through the door. I don't know what he was doing in Oxford either. I've certainly forgotten now. And so Stephen generously went off to buy the drinks and brought them over and put them down on the table. And as he put his pint of beer down, he spilt it. And I sort of said genially, oh, heavens, drinking at this time of day. And he then told me that he'd been in Addenbrooke's for 3 weeks, and they'd done a whole series of tests, and they'd decided what was wrong with him. And he told me very straight and flat that he was gradually going to lose the use of his body, that eventually only his heart and his lungs would still be operating, and his brain. And that they had told him that eventually he would essentially have the body of a cabbage, but his mind would still be in perfect working order, and he would be unable to communicate with the rest of the world.
My dreams at that time were rather disturbed. Before my condition had been diagnosed, I had been very bored with life. There had not seemed to be anything worth doing. But shortly after I came out of hospital, I dreamt that I was going to be executed. I suddenly realized that there were a lot of worthwhile things I could do if I were reprieved.
I knew perfectly well that he had no faith. And to me, that made it the more difficult, because you must ask yourself, why me? Why this? Why now? But he just totally, flatly accepted that this was what was going to happen to him. And as far as I can gather, at that point, he started to do some work.
At first, there did not seem much point in working at my research, because I didn't expect to live long enough to finish my PhD. However, as time went by, the disease seemed to slow down. I began to understand general relativity and make progress with my work. But what really made a difference was, I got engaged to a girl called Jane Wilde. This gave me something to live for, but it also meant that I had to get a job if we were to get married.
Stephen was already ill. Jane knew it. And it was another instance of Stephen's luck. You know, meeting the right person at the right time. Because Stephen was very, very badly depressed. And he wasn't really very much inclined to go on with his work. I mean, he'd been told he'd only got 2.5 years. What can you do in that time? But meeting Jane really put him on his mettle. And he started to work.
I wanted to understand how the universe began. Einstein's theory of general relativity showed that the universe was expanding. But there was no answer to the crucial question, must there have been a Big Bang, a beginning to time? Then, in my 3rd year at Cambridge, Roger Penrose made his discovery about the death of stars.
I remember talking to this friend, Ivor Robinson, and we were having a sort of very animated conversation. And then we had to cross a road. And as we crossed the road, of course, the conversation stopped. And then we got to the other side. Well, evidently, I had some idea in crossing the road, but then the conversation started up, and it got completely blotted out of my mind. And it was only later, after my friends had gone home, I began to have this strange feeling of elation, feeling wonderful. And I couldn't figure out why on earth I should feel like that. So I went back over the day thinking all possible things which might have contributed to such a feeling. And then gradually I unearthed this thought which I'd had while crossing the street.
Penrose announced this result, that when stars collapse indefinitely, they will become singular, as long as some very broad conditions are satisfied that everybody would have regarded as reasonable. And I remember Stephen Hawking, who was then approaching his 3rd year as a research student, saying, "What very interesting results. I wonder whether they could be adapted to understanding the origin of the universe." And what he had in mind, you see, was that if just mentally you reverse the sense of time, you can think of the expanding universe as a collapsing system. It's a bit like a giant, very giant star collapsing.
Roger Penrose proved that a dying star, collapsing under its own gravity, eventually shrinks to a singularity, a point of infinite density and 0 size. I realized that if I reversed the direction of time so that the collapse became an expansion, I could prove that the universe had a beginning. But my proof, based on Einstein's theory of general relativity, also showed that we cannot understand how the universe began, because it showed that all scientific theories, including general relativity itself, break down at the beginning of the universe.
We had this meeting at the Institute of Space Physics in New York. I said before we reach a final conclusion, we ought to throw into the pot still another object, a gravitationally completely collapsed object. Well, after you've used the phrase, a gravitationally completely collapsed object, 10 times, you conclude you've got to get a better name. So that's when I switched to the word black hole.
The word black hole, which John Wheeler coined, suddenly caught on. Everybody adopted it, and from then on, people around the world, in Moscow, in America, in England, and elsewhere, could know they were speaking about the same thing. And not only that, but it suddenly, the whole range of concepts got through to the general public, and even science fiction writers all of a sudden could talk about it.
Tonight, my friends, we stand on the brink of a feat unparalleled in space exploration. If the data on my returning probe ship matches my computerized calculations, I will travel where no man has dared to go.
Into the black hole?
In, through, and beyond.
Why, that's crazy. Ha! Impossible.
As a massive star contracts, its gravity becomes so strong that light can no longer escape. The region from which nothing can escape is called a black hole, and its boundary is called the event horizon. One might say of the event horizon what Dante said of the entrance to hell. Abandon all hope, ye who enter here.
I was once asked to actually be an adjudicator on an essay of which the subject was how to fall through a black hole and live. Now, the problem I had was that I wouldn't know how to give out the prize, because if I said, well, that looks like a good essay, the only real way of showing that this was right was to actually follow it, to do the experiment and fall in. But then, having fallen in, I would assume taking the person who wrote the essay with you, the question would be, how do you tell the rest of the world? Do you take the prize in with you that you give to them? And what do they do with it when they get to the center?
Believe me, I've been waiting a long time for someone like you to record this moment.
Thank you, Doctor.
Then I'm ready. Ready to embark on man's greatest journey.
Certainly his riskiest.
The risk is incidental compared to the possibility to possess the great truth of the unknown. There, long-cherished laws of nature simply do not apply. They vanish.
And life?
Life? Life forever.
If you were watching an astronaut foolhardy enough to jump into a black hole at some time on his watch, say 12 o'clock, he would cross the event horizon and enter the black hole. But no matter how long you waited, you would never see the astronaut's watch reach 12 o'clock. Instead, each second on the watch would appear to take longer and longer, until the last second before midnight would take forever. Thus, by jumping into a black hole, one could ensure that one's image lasted forever. But the picture would fade very rapidly, and grow so dim that no one could see it.
as somebody disappears into a black hole, as seen from the outside, it looks as though the time actually slows down, and the person becomes who's moving, at least he's thinking, he's moving, he's perhaps talking in his spaceship at a normal rate, seems to slow down and ends up by being frozen in a particular position, as seen by somebody watching him from the outside. And as seen from the outside, you never see what happens after that.
The astronaut wouldn't notice anything special when his watch reached midnight and he crossed the event horizon into the black hole. Until, of course, he approached the singularity and was crushed into spaghetti.
One can fall through this event horizon without feeling anything, without noticing it. After about a week of falling, one begins to feel the pinch and one extends longer and longer and gets slightly thinner. And, of course, one begins to get squeezed. Until one gets very long and very thin and rather nasty. By the end of 2 weeks, one's fallen right into the center and one is, of course, dead.
Before you lose sight of the outer world, you would see things happening, and you would see them at a greater rate, so that it would look like a firework display. The frustration would be that although you would be able to see everything that happens in the future, it would be going so fast that from a scientific point of view, you would have no time to analyze it. You wouldn't be able to take it in. And eventually things would be going off so fast and it would be so explosive that you yourself would be destroyed by the explosion, and that would be the end. But it would be a very exciting way to end one's life. It would be the way I would choose if I had the choice.
In the long history of the universe, many stars must have burned up their nuclear fuel and collapsed in on themselves. The number of black holes may be greater than the number of visible stars, which totals about 100,000 million in our galaxy alone. We also have evidence that there is a very large black hole at the center of our own galaxy.
Friends ask me, well, if a black hole is black, how can you see it? And I say, have you ever been to a ball? Have you ever watched the young men dressed in their black evening tuxedos and the girls in their white dresses whirling around, held in each other's arms, and the lights turned low, and all you can see is the girls? Well, the girl is the ordinary star, and the boy is the black hole. You can't see the black hole any more than you can see the boy, but the girl going around gives you convincing evidence there must be something there holding her in orbit.
One evening, shortly after the birth of my daughter, Lucy, I started to think about black holes as I was getting into bed. My disability makes this rather a slow process, so I had plenty of time. Suddenly, I realized that the area of the event horizon must always increase with time. The increase in the area of the event horizon was very reminiscent of a quantity called entropy, which measures the degree of disorder of a system. It is a matter of common experience that disorder tends to increase with time if things are left to themselves.
Jacob Bekenstein came into the office one day. Jacob, I said, it always troubles me when I put a hot teacup next to a cold teacup. I've increased, by letting heat flow from one to the other, the amount of disorder in the universe. But Jacob, if a black hole swims by and I drop both teacups into this, I've concealed the evidence of my crime, have I not? Bekenstein's a man of great integrity, and he looked troubled, and he came back to me later, and he said, "No, you have not concealed the evidence of your crime. The black hole records what's happened to you." Stephen Hawking read the paper in which Bekenstein announced this result, thought it was preposterous, and decided to prove it was wrong.
My discoveries led Jacob Bekenstein to suggest that the area of the event horizon actually was the entropy of a black hole. But there was one fatal flaw in Bekenstein's idea. If black holes have an entropy, they ought to have a temperature. And if they have a temperature, they ought to give off radiation. But how could they give off radiation if nothing can escape from a black hole? As it turned out, Bekenstein was basically correct, though in a manner far more surprising than he, or anyone else, had expected.
As he gradually lost the use of his hands, he had to start developing, carefully choosing research projects that could be tackled and solved through geometrical arguments that he could do pictorially in his head. And he developed a very powerful set of tools that nobody else really had. So in some sense, when you lose one set of tools, you may develop other tools, but the new tools are amenable to different kinds of problems than the old tools. And if you're the only master in the world of these new tools, that means certain kinds of problems you can solve and nobody else can.
My work up to 1973 was in general relativity, and was summarized in a book I wrote with George Ellis, called The Large-Scale Structure of Space-Time. Even then, it was difficult for me to write things down. So I tended to think in pictures and diagrams that I could visualize in my head.
I remember visiting Stephen and Jane at their home in Cambridge. After supper in the evening, when it was time for Stephen to go to bed, Jane insisted, and Stephen acquiesced, I guess this was standard, that Stephen make his way up. I've forgotten whether it was one flight of stairs or two flights of stairs alone, and this was a period when he could no longer walk. The way he got up the stairs was he grabbed hold of the pillars that support the banister and pulled himself up the strength of his own arms, dragging himself up from the ground floor on up to the second story in a long, arduous effort. Jane explained that this was an important part of his physical therapy to maintain his coordination and strength as long as possible. At first, it was sort of heart-rending to watch what appeared to be the agony of pulling himself up the stairs until I understood it's just part of life, pulling himself up the stairs like that.
General relativity is what is called a classical theory. It predicts a single definite path for each particle. But according to quantum mechanics, there is an element of chance or uncertainty. A particle does not have just a single path through space and time. Instead, there is an uncertainty principle, according to which both the exact position and velocity of a particle can never be known. I began investigating the effect quantum mechanics might have on particles near a black hole. I found that particles could escape from a black hole, that black holes are not completely black. At first I didn't believe it, but when I redid the calculations, I couldn't get the effect to go away.
I met Martin Rees, and he was shaking with excitement. And he said, "Have you heard what Stephen has discovered? Everything is different, everything is changed."
I was still unsure of my discovery, so I only told a few colleagues. But word soon spread. Roger Penrose phoned up on my birthday. He was very excited, and went on so long that my birthday dinner got quite cold. It was a great pity, because it was goose, which I'm very fond of.
To me, it's a miracle, because it's a complicated and messy calculation. We can now do these things very much better, and it's more transparent what happens. But out of this messy calculation, he showed that black holes aren't black with this quantum mechanical effect. There was a residual radiation. Stephen came to a meeting, and people were flabbergasted. And I remember someone getting up and saying, "You must be wrong, Stephen, I don't believe a word of it."
I once said that I was unhappy with the explanation given in terms of negative energy particles being created. But I feel this is part of the controversy of science. You must have the give and take. And I'm delighted to be able to be part of that. I mean, that's what makes it fun. You know, if you all sat down and said, "Oh, lovely," when you do have niggling questions in your minds, that's not doing a service to science. But I was not antagonistic to it in any way, except for that one time when I questioned.
I finally convinced myself that black holes radiate when I found a mechanism through which this could happen. According to quantum mechanics, space is filled with virtual particles and antiparticles that are constantly materializing in pairs, separating, coming together again, and annihilating each other. In the presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the black hole. And so, black holes are not eternal. They evaporate away at an increasing rate until they vanish in a gigantic explosion. Quantum mechanics has allowed particles and radiation to escape from the ultimate prison, a black hole. Einstein never accepted quantum mechanics because of its element of chance and uncertainty. He said, "God does not play dice." It seems that Einstein was doubly wrong. The quantum effects of black holes suggest that not only does God play dice, he sometimes throws them where they cannot be seen.
He says himself that he wouldn't have got where he is if he hadn't been ill. And I think that's quite possible, because it's like Johnson said, you know, knowledge that you're to be hanged in the morning concentrates the mind wonderfully. And
People had